Hey guys, this is part 2 for preparing solutions, and in this video we're going to take a look at how we can relate mass, moles, and volume. So how we can convert between the three of them using molarity as well as using the molar mass. Okay, so we're just going to kind of fill out this table here below using the table up here. Okay, so I just kind of crossed some of the numbers out so that we can kind of simulate what it would look like if we had to fill in this table on our own, which you might have to do in the problem handout sheet you'll see after this video. Cough, cough. So we'll start with sample 1, looking at the moles, or trying to solve for the moles, and the equation we're going to use is molarity times volume, right? Because we've seen that molarity is moles over volume. So if we move things around to solve for moles, we just have to take the molarity and times it by volume, which in this case is 1.0 molarity times 1.0 liters, and that should be 1.0 moles. Double check our work. There it is. Good. So for the second one, volume, sample 2, for volume, we're going to do moles divided by molarity. Right? Again, using that same equation, we're just kind of manipulating it or moving it around so that we can solve for our unknown. So in this case, we're taking moles, which is 0.10 moles, divided by molarity for sample 2, which is 0.10. Right? Just take that one number and that number, and we do that, and we see that they can both cancel out, so the volume is going to be 1 liter. We double check, and we see that that is correct. All right, third one is molarity, and that was our big equation or big focus for these videos. That's moles over liters. So in this case, for sample 3, we take 0.10 moles and divide it by 0.10 liters. We'll see that these will cancel out again, and our molarity should equal 1 molar. We see that is also correct. And for the last one, for mass, this is where we are going to be using the molar mass. Right? So we're going to take these numbers. In this case, we're looking at sucrose. So we take the molar mass of sucrose, and if we had to do it ourselves, we would look at the periodic table, add and multiply all of those numbers up. In this case, it's given to us. Molar mass of sucrose is 342.3 grams per mole. And so for sample 4, we're just going to take our moles and times it by molar mass. Right, we've done this on tests and quizzes before. I know it can be confusing though when we have all of these other units and equations we have to work with, but this is how we get the mass or grams. So for sample 4, we take 342.3 grams per mole, and we times it by our moles, which is 0.01 moles. Those units will cancel, and if we do this, it should be 3.423 grams. Oops. Boy. And all right, there we go. And if we check our work again, we can see that that is correct. Okay, so just be able to use this table. These equations can be helpful with filling out the table or answering questions based off of moving from one to the other. And then for the last question, how many ways is there to make a 0.10 molar solution? The answer is many. But if we look specifically above at the table, there are 2 ways, right? Because if we look at sample 2, we can see we have 0.1 moles divided by 1 liter, of a solution, that will get us to that number. But also if we look at sample 4, 0.01 moles divided by 0.1 liters, that'll give us the same number. So again, concentration isn't necessarily how much you have of something, just how much you have it relative to the solution, right? Because if you have less solution, you will need less moles. Okay. So just be aware of that too as you're making solutions or solving for solutions, right? There's many ways to make one concentration of something. All right, so this is our last problem for the lesson. Safe drinking water. So arsenic, AS, is an element that is found naturally in the soil. As a result, tiny levels of arsenic are often found in some water supplies. Like that of all substances, the toxic effect of arsenic is dependent on the dosage you received. For this reason, the Environmental Protection Agency, EPA, sets limits on the amounts of dissolved substances that can be present in our drinking water. The EPA has set the upper limit for arsenic in drinking water at 0.00010 grams per liter. I'm going to be saying a lot of zeros in this problem, just bear with me. Okay. So basically, if we have a number above that, we have too much arsenic, and that's going to be sad. That's going to be lethal towards someone. Okay. So we have the sample, pretend we're working for the EPA. We got the sample of drinking water that has a concentration of 0.00002 molarity of arsenic. So we want to basically know, is this too much? Is this too much arsenic? So we have our first number, which is in grams over liters. We have our second number. This is the sample. Right? And we can rewrite this as moles over liters. So really, the liters are going to stay the same. The thing we just have to do is convert moles into grams or grams into moles. And to do that, hopefully we were familiar with this, we use our molar mass. So the molar mass we're going to find on our periodic table. So if we go there now, we are looking for arsenic, which is right here. If we just grab that. There we go. So arsenic has a molar mass of 74.92 grams per mole. Now you could do either one here, as long as you know how to answer the question. For this one, we're going to take the sample. Okay, so we're going to take 0.00002 moles over liters, and we're going to take the molar mass, and we're going to times the two together. All right, so 74.92 grams over moles. Our units will cancel, and so if we do that, we should get, let's see, 0.0015, we'll just round it, grams over liters. All right, those are our two units left. All right, so now we have to take a look at this number and compare it with our starting number. Is this number higher than that one? Yes. What does that mean? That means this will be deadly, right? Because this is too much arsenic in normal levels of drinking water and could prove lethal to people. Okay, so as the EPA, you would probably create regulations or policies that would limit the amount of arsenic in sample or drinking waters and then provide safe drinking water for all. All right, so that was the two example problems, and hope you enjoyed that, guys. And that was the T. I will talk to you guys soon.